In 1999, scientists stumbled upon a hidden gem in the depths of space, 40 light-years away, TRAPPIST-1, a small but mysterious red dwarf star. Back then, they had no idea they had stumbled upon an astronomical treasure trove. 17 years later, modern telescopes began to reveal the secret. The first 3 planets orbiting the star were discovered. And just a year later, 4 more were revealed, as if the universe were telling a magical story. Have you ever imagined a distant planetary system where each world resembles our own Earth? Today, TRAPPIST-1 has become the most studied planetary system outside our solar system. Its 7 worlds are rocky, roughly the same size and mass as Earth, and some may even contain more water than our oceans. For a long time, exploring distant planets was a dream come true. But that all changed when the James Webb Space Telescope, JWST, was launched, a brilliant guide to the mysteries of the cosmos. So, is the TRAPPIST-1 system habitable? What would it be like to live on one of these worlds? Let's take a journey of discovery. JWST was designed to look back to the early universe, when the first stars and galaxies formed. But what really sets it apart is its ability to analyze the atmospheres of distant exoplanets. Imagine, a powerful machine that can peer through dense clouds to tell us about the geology and climate of worlds tens of light-years away. JWST uses cutting-edge instruments like the near-infrared spectrometer and the mid-infrared instrument, which measure the spectrum of light from distant celestial bodies. This allows scientists to determine the chemical composition and temperature of the planet's atmosphere. Furthermore, JWST's powerful infrared camera can see through thick clouds, revealing geological details as vivid as a cosmic painting. But not everything is easy. TRAPPIST-1 is an M-type red dwarf star, the most common type of star in the Milky Way, but also extremely active. Powerful plasma eruptions from this star occur several times a day, making it difficult to distinguish normal light from radiation from the eruptions. Fortunately, JWST is no ordinary telescope. Its accuracy is like looking at 10,000 light bulbs and noticing exactly 4 that have gone out. So what has it discovered about the TRAPPIST-1 system? Recent observations suggest that the closest planet to the star, TRAPPIST-1b, may be a bare rock with a thin or no atmosphere. With a surface temperature of 230 degrees Celsius, the planet is as hot as a furnace, like Mercury in our solar system, well outside the habitable zone. A little further away, TRAPPIST-1c, the second planet, was once thought to be a Venus-like planet with a dense atmosphere. But JWST has revealed the truth: the planet has no atmosphere like Venus. Its daytime temperature, though still a scorching 107 degrees Celsius, is the lowest ever recorded on a rocky planet using this new method. In such extreme conditions, water, if it ever existed, would have evaporated long ago. But the story doesn't end there. The remaining planets in the TRAPPIST-1 system are waiting to be discovered, and perhaps, somewhere among those distant worlds, there are still secrets waiting to be revealed. In the dance of planets orbiting the red dwarf star TRAPPIST-1, some of these worlds may be cool enough to harbor water in liquid or icy form. Imagine a vast ocean, shimmering under the red glow of its parent star, where water can survive the intense heat of space. Of the 7 planets in the system, TRAPPIST-1d stands out as a tiny gem, just 30% the mass of Earth and about 80% the radius of our planet. Light and graceful, it resembles a miniature version of our beloved blue home. But could such a tiny world harbor life? With its modest mass, TRAPPIST-1d is unlikely to retain a dense atmosphere or contain many heavy elements. However, it does receive the same amount of radiation from its parent star as Earth. Located just outside the habitable zone, the planet has a surface temperature of around 9 degrees Celsius without an atmosphere, cool enough to make you think of a chilly morning on Earth. By comparison, without the greenhouse effect, our planet would be a chilly -17.5 degrees Celsius. But what makes TRAPPIST-1d so amazing? Scientists believe the planet could hold 250 times more water than Earth's oceans. Imagine a world where giant waves stretch out endlessly, reflecting the red glow of the dwarf star. A key factor in TRAPPIST-1d's habitability is albedo, the surface's reflectivity, measured as the percentage of sunlight that is reflected back into space. Albedo ranges from 0, when all radiation is absorbed by a perfectly black surface, to 1, when all light is reflected by a perfectly white surface. Earth has an average albedo of about 0.3, and if TRAPPIST-1d had a similar value, it could create an ideal environment for life. Water vapor, though a greenhouse gas, could help the planet avoid extreme greenhouse conditions if the albedo were well balanced. Scientists dream of a TRAPPIST-1d covered in a global ocean, where the water sparkles like a giant mirror in the dim light. But for life to truly thrive, TRAPPIST-1d needs a special energy source, tidal heat flows, 20 times more powerful than Earth's. This energy, generated by gravitational interactions with nearby bodies, acts as geothermal heat, driving chemical reactions in the deep ocean. On Earth, some organisms rely on chemosynthetic life, which derives its energy from chemical reactions rather than sunlight. Could TRAPPIST-1d be home to unique life forms that don't need light to survive? If the planet has a thin atmosphere, the twilight zone, the place where day and night intersect, could be a potential oasis for life. In the TRAPPIST-1 system star cluster, TRAPPIST-1e, the fourth planet, stands out as the most likely candidate. Its high density, rocky composition, and close chemical makeup make it a distant cousin of our own. Located right in the heart of the habitable zone, TRAPPIST-1e may have an oxygen-rich atmosphere. Hydrogen, a greenhouse gas, may have escaped the atmosphere because of its light nature, good news for the planet's climate. If TRAPPIST-1e started out with more water than Earth and Mars, and managed to retain it on its surface for billions of years, its climate could be identical to the balmy days of Earth. Can you imagine a world where a year lasts only 7 Earth days, and the concept of day and night is completely different? TRAPPIST-1e is considered one of the most Earth-like planets ever discovered. But what awaits us on worlds farther out in the system? Imagine standing on a distant planet whose sky is a deep crimson of eternal twilight. The 7 planets in the TRAPPIST-1 system, so close to their red dwarf parent star, are tidally locked. One side always faces the star, the way the moon shows Earth its side. One side is bright and bright, the other is in cold darkness. Have you ever wondered what it would be like to live on a world where day and night never change? Beneath the crimson sky, you look up and see 6 other planets hovering like giant moons, some larger than Earth's moon. On the day side of TRAPPIST-1e, Earth could be where humans dream of a new life. The climate here is unlike any other on Earth. Thick storm clouds cover the sky, and giant dust storms carry heat, creating the temperature balance needed to sustain complex ecosystems. But don't let the beauty fool you. Strong winds, tornadoes, and violent storms are also part of the picture. On the other hand, the night side is a harsh world where towering glaciers reign in the bitter cold, challenging even the bravest explorers. While the endless twilight may be tiring, it offered a unique advantage to the first settlers. On Earth, our ancestors relied on constellations to navigate. But on TRAPPIST-1e, the mother star is always fixed in the same place in the sky, like an eternal North Star, many times larger than our Sun, guiding the way through unfamiliar lands. Imagine walking across a rocky field, its red light shining down, and it's always there, like a companion that never leaves. In the Milky Way, red M-type dwarfs like TRAPPIST-1 outnumber Sun-like stars by 10 times. These red-hot little guys are potential cradles for life, with trillions of years to evolve in their cosmic neighborhood. But don't think they're benign. Though usually dim, red dwarfs can suddenly flare up with powerful plasma eruptions, as if the star is releasing powerful storms of energy. What's the magic? Some scientists believe that the eruptions from TRAPPIST-1 could be key to the start of life, providing the energy to create important molecules like amino acids, the building blocks of life. However, the high energy of the eruptions can also be dangerous. They can scorch the planet's surface or strip away its atmosphere. Fortunately, TRAPPIST-1 is a more benign star, with eruptions 30 times weaker than those of its red dwarf cousins. Still, because the 7 planets in the system are so close together, the effects of the eruptions are still significant. On TRAPPIST-1e, the auroras would be a spectacular sight, unlike any northern lights you've ever seen. These brilliant bands of light are not only beautiful, but also a natural alarm bell, warning of energy storms from their parent star. To survive, humans on TRAPPIST-1e would need an atmosphere with a much thicker ozone layer, a powerful magnetic field, and advanced technology to monitor eruptions. Settlements would be built like fortified fortresses, with protective shells and life support systems, ready to serve as shelters when cosmic radiation hits. Every home, every community would be equipped to deal with these unexpected storms. But the story of TRAPPIST-1 doesn't end here. The remaining planets, each with their own secrets, are waiting for us to explore. Could any of these worlds really be a new home for humanity? Imagine walking on TRAPPIST-1e, where gravity is only slightly less than Earth's, at around 93%. You almost feel like you're walking on your home planet, but then an energy storm from the red dwarf hits. Plasma eruptions, though weaker than those on other red dwarfs, are still a threat. If you don't find shelter in time, your body could suffer serious damage, blood vessels constrict, restricting blood flow, leading to serious health problems. Worse, this harsh radiation can damage the DNA in your cells, causing mutations or abnormal cell growth. Have you ever thought about living on a planet where every day is a battle against space storms? In the endless twilight world of TRAPPIST-1e, growing plants becomes a conundrum. The light from the parent star shines at a low angle, creating long shadows that hinder plant growth. But humans always find a way to overcome difficulties. Imagine magical hanging gardens, inspired by ancient Babylon, where trees hang from high floors, reaching out to catch every ray of red light. The beds are stacked on top of each other, cleverly designed to filter light through gaps, ensuring that even the plants on the lower floors still get a little light from the sides. Every little corner of the garden is optimized, just like nature creates dense forests where not a single ray of light is wasted. If TRAPPIST-1e has native plants, they may have evolved to be special. Imagine pitch-black forests, absorbing every ray of light to survive in the low light. Some species may even be bioluminescent, emitting a dim glow to prolong their growth in eternal darkness. These sparkling gardens would be a magical sight, like tiny stars falling to the ground, lighting up the hope of life. Further out in the system, TRAPPIST-1f receives only about a third of the sunlight that Earth does from the sun, making it a frigid world. Without an atmosphere, its surface temperature could drop to -59 degrees Celsius, turning any water into ice. The two most distant planets, TRAPPIST-1g and TRAPPIST-1h, face a similar fate, with surfaces that could be covered in ice, despite data suggesting they are water-rich. But TRAPPIST-1g, which is about 30% more massive than Earth, could retain an atmosphere. If the planet is volcanically active, spewing out greenhouse gases to maintain an atmosphere, it could be a world of liquid water. Scientists even dream of a subsurface ocean as deep as 670 kilometers, nearly 200 times the average depth of Earth's oceans. Can you imagine such a deep ocean, harboring exotic life forms, waiting to be discovered? In the farthest corner of the TRAPPIST-1 system, the seventh planet, TRAPPIST-1h, lies in the frigid zone, with a surface temperature of around -100 degrees Celsius. If it were in our solar system, it would hover somewhere between Mars and Jupiter, bathed in darkness. The 7.6 billion-year-old star TRAPPIST-1 is slowly cooling. In the past, nearby planets endured harsh conditions due to their high temperatures, but now they tell a different story, one of potential life in seemingly impossible conditions. The story of the TRAPPIST-1 system is not yet over. These worlds, from icy oceans to bioluminescent gardens, beg us to explore further. Imagine a time long ago when the red dwarf star TRAPPIST-1 burned with enough heat to turn any water on its planets into vapor, which hung in the atmosphere. Harsh stellar winds then swept through, carrying the vapor into space, seemingly wiping out any hope of life. But the universe is full of surprises, isn't it? Astronomers, using new models based on real data, have painted a completely different picture of the fate of the 7 worlds in the TRAPPIST-1 system. It was previously thought that heat from the planet's surface escaped through convection, the same way hot air rises and cold air sinks in your kitchen. But planets aren't so simple. Their atmospheres are a complex puzzle, with gases that behave differently at different altitudes. New research suggests that the TRAPPIST-1 planets may not have been heated to the point where their crusts and mantles turned to molten rock. Instead, significant amounts of water may have been trapped, hidden deep within the crevices of their parent star, even as their parent star slowly cooled over billions of years. Imagine oceans locked in rock, like precious gems waiting to be discovered. Right now, conditions on these planets can be harsh, from scorching heat to freezing cold. But don't forget, red dwarf stars like TRAPPIST-1 are known for their incredible longevity. Its 7 worlds have billions, even trillions, of years to evolve through countless stages. One day, lands that are now as hot as furnaces or as cold as ice could become oases teeming with life, like lush gardens under the fiery glow of their parent star. Can you imagine a future where these planets become new homes for life, just like our Earth is today? In the coming years, the James Webb Space Telescope, JWST, will continue to unravel the mysteries of these Earth-like planets. Each new observation is a window that brings us closer to the answer to the question of the potential for life in the universe. What do you think about the possibility of finding life in our own cosmic neighborhood? The discoveries that are coming will continue to amaze us, and we will bring you the latest news from space. But there is much more to the story of TRAPPIST-1. What other secrets are hidden in this fascinating planetary system?